At the forefront of a global shift, a new kind of worker steps in. Eyes in metal, judgment in code, and built for 24/7 duty.
下一波最大的工业上面的变革就是机器人。
In Taiwan, the promise becomes practice. Collaborative robots refined not to replace people, but to work at arm's length.
这个就是我们带来的让终端客户最大的价值。
This is not just automation. It's the beginning of a deeper partnership between human intuition and machine intelligence. Safer, steadier, closer. Quietly reshaping the future. It all begins with cold metal, silent and still. Then motors awaken, breathing motion into stillness. A mechanical symphony, parts moving in perfect rhythm. But that's not enough. You wanted to see, to sense the world around it, and finally, to grow intelligence, to think, and to respond. The near future walks in on two metal legs. Perhaps sooner than expected, everyday life could look like this. AI-driven humanoids everywhere. On the factory line, in the operating room, at the checkout, and finally, crossing the threshold of every home. That unprecedented market potential has ignited a global R&D race among the world's top technology companies.
第一个蛮大的改变就是驱动系统的进步，至少有足够的力道，让今天做一个狗就可以跑来跑去，做一个人也可以做一些我们人甚至做不到的后空翻、前空翻这些比较剧烈的动作。那第二个最大的改变当然就是 AI。
好像那个外面站起来。
那 AI 的东西就是很特别，就是它可以用快速的运算方式，它可以接到，例如说视觉的一些讯息、图片的讯息，然后声音的一些讯息，或者是触觉的一些讯息。那人形就会像人一样，它有大脑，它可以思考，它可以因应环境的变化去做一些调整，然后它可以来自己做决策。
AI moves at light speed, giving strong machines the mind to tackle complex work. But does that mean a total handover from humans? Now?
我觉得还需要一些实践，因为等于说今天真的要导入到不管是工业的产线上面，或是真的进到我们所谓的服务机器人来真实使用，我觉得它的性能跟价格没有到所谓的黄金交叉，因为今天等于说机器人本身还是很贵，那真正能做的事情可能也不是很多，然后现在跟人比，很多的事情稍微慢了一些。
A mechanical partner with human agility may still be years away. Yet another kind of robot is already here, quietly embedded in daily life. This isn't a show. It's the final trial. Over 72 hours, each robotic arm cycles through extreme poses and paths without pause. The requirement is non-negotiable. Joints, vision, and control must hold steady under full load. Thomas Chung stands at the factory's last gate. His rule is simple. No unit ships until it survives the endurance marathon.
我们就是会依据最大规格的负载，然后将把手臂调到一个规格的一个最大的上限去做测试。这种极端的一个测试的情况之下，手臂如果还是能通过这3天的测试，代表这个手臂的功能是发挥到极致。
Under full load, each arm must draw 840,000 perfect circles and return to the same datum every time. Allowable drift is thinner than a human eyelash, the standard of fine watchmaking. If anything slips, the answer is no.
在测试的过程中，如果有异常的状态的话，当然手臂会停机。操作的人员他可以精准的可以看得到哪只手臂、哪个位置跟哪个错误的 error code， 我们会依据这个手臂的 error code 会进行一个故障的排除。那个是光源那个是比较弱，你检查一下。
These trials are only rehearsal for deployment. Their destination, the world's leading semiconductor clean rooms, where exacting precision is crucial. It's called a collaborative robot, a cobot. At first glance, it's simply a robotic arm. But in purpose and behavior, it's something else entirely. In traditional production lines, industrial arms are massive, high-powered machines, moving with blinding speed behind safety fences to keep people out of harm's way.
早期的机器人其实没有那么的聪明，所以他只知道说我今天的手大概动到哪里，他没有办法很清楚的跟很智慧的去看到我现在环境的状态，有点像是跟环境其实是没有互动跟反馈。
That's what the Cobot changes. Compact, vision-guided, and sensor-aware. It reads the workspace and adapts in real time. Built to share human space and blend human-like flexibility with robotic precision. And in Taiwan, one place stands at the heart of that shift. Taoyuan, the island's logistics nerve, where runways meet assembly lines. An hour from Taipei and the world's chip epicenter, the district compresses into a compact high-tech cluster. Within it, TechMan Robot, Taiwan's flagship in collaborative robotics, ranked number 2 worldwide. But here, scale isn't measured in acres. No endless clean rooms, no kilometer-long lines. This mega factory plays a different game: intelligence density.
我们一开始的定位就希望是一个够智慧化的协作型手臂，就像人够聪明，你就弹性大，你可以做很多事情。所以我们会把 AI、把视觉，还有我们未来还会加更多的 sensor 在我们的这些手臂上，让它的智能化再更提高。
From design, assembly, test, to pack and ship, everything runs on a tight, precise cadence. Small footprint, big throughput. It may look fully robotic, but at the origin, human judgment lays the rails. What the robot must do, how precisely, and with which components. The measure that matters is simple: a happy customer.
重要的精神就是简单、好用、安全。我要做到多准，视觉要到什么程度，系统要到什么程度，其实这很多事情我们从我们这边解决，所以客户拿到的就是一个 ready to use 的这样子的产品。
Engineers lock in what can scale: arm length and joint layout, reach and payload, the vision stack and sensors. Above all, a brain that understands the scene.
要让机器人看得懂完清，就是视觉。但是你要怎么从照片去拿到你要的这个资讯，这就是算法。所以我们投入了非常多的研发成本在这些算法上面的开发。
Safety is designed in from day one. First principle, a robot that yields first. Mass stays low, edges are rounded. And an independent safety watchdog can halt it in a blink.
协作型手臂最大的一个差异跟传统型手臂就是安全，我们是会自动侦测自己施加的力量。当有跟人体有一个比较大的力量接触的时候，我们手臂会自动感测、自动停止，因为知道外部力量太大。
And teaching no longer means lines of code. Hand guiding sets the path. The arm moves only when led, at low speed and low force, so the motion taught is simple, safe, and repeatable. But how do engineers decide the movement? The idea comes from the most proven blueprint we have. Imagine your arm. The shoulder turns to face the task, lifts forward or out, even rolls the upper arm. The elbow bends to close the gap. The wrist tilts and twists to line up the hand.
我们在讲人的时候，其实一只手相当于是7颗马达，就相当于这边有3颗，这边有1颗，然后这边有1颗，这边有2颗，所以你最少需要6颗马达才能让你的手在我们现在的所谓的3维的空间里面动得很顺。那人的设计是有多一颗叫做冗自由度，就等于说你手伸过来的时候，万一中间有障碍，你有多一颗马达可以做一些调整。
Now, cut to the Cobot. It mirrors that choreography.
手背在走的时候，除了这一个 X、Y 方向、Z 方向之外，我们可能还要这样子旋转吧，或者是抬头，或者是这样子旋转，这样子总共有6个走向。
6 joints, 6 moves. Turn, reach, rotate. Tool on target, angle locked, hour after hour. With the motion set, the build shifts to modules. Joints, vision, control. Each is assembled and proven on its own before it earns a place on the arm. For engineering director John Huang, pushing the process to peak output is job one. In his world, the Cobot is more than inventory.
我是学计算机的啊，那压根也没有想过我可能会做机器人。我认为机器人对我来讲是一个工作的伙伴。
On this automated line, the faithful teammate helps build itself. The process runs with disciplined efficiency. Today's assignment is precise. Assemble the joint's core. A team of cobots works in concert, picking, seating, and torquing a stack of ring-shaped parts into one exact unit.
早期人工来组的时候，这一段我们可能要花个是15分钟一颗。那目前来讲的话，大概就是1 1分钟60秒，对，大概差了15倍。
First, make round things truly round in motion. A quick run-out check so nothing wobbles. Then, set the squeeze. Tight enough to remove slack, not so tight it drags. Finally, the finished core is released from the fixture. It's the hidden secret that powers the arm's smooth, precise motion. Its name? Harmonic drive. A compact reducer inside the joint that trades motor speed for torque and accuracy. It works with 3 parts. A rigid ring gear, a thin flexible cup gear with slightly fewer teeth, and an oval wave generator. As the generator spins, it gently ovalizes the flex spline, so its teeth engage the ring at 2 opposite zones that walk around the circle. Because the flex spline has fewer teeth, the output advances only a tiny step per motor turn. Many fast spins in, one slow, strong step out.
最大的问题是齿轮都有背隙，齿轮到后面的末端就是一个不可控的范围，会在那边晃动。你经过越多对，它的背隙就会累加。那时候用普通的齿轮的时候，其实大家想说，所有的马达都不动，双脚站了之后，身体就会一直晃来晃去，根本就没有办法做控制。改成斜波减速机之后，才让机器人比较容易的站立，然后可以开始做控制。所以那个真的是一个蛮关键的零组件啊。
The core then locks and seals with its motor and encoder. Simple to watch, decisive in outcome.
其实，在我们的制程上面是最关键的是在于肘关节，在组装上面有分3道的锁腹，好，初始的锁腹，好，然后再来1/2半力，再来全半力。那我们是一个很平面的，慢慢的往下面锁。啊，这一站的话，如果是我们没有锁好的话，就会可能会造成异音啦，那也有可能会造成一些的抖动。
Before the line moves on, each joint must prove 2 things. It works, and it turns freely, obeying commands with smooth, in-spec rotation. Once the lights go green, the arm comes together.
手背组装的话，它有点像组个大楼一样人家讲的是说万丈高如平地起嘛，所以我们也是从base会先组装。
And then joints stack on, each unlocking another way to move. Links, the rigid bones that connect the joints, draw the geometry into one clean line. A wiring harness then threads the hollow spine, so power, sensors, and control can ride like nerves through a body. Finally, the vision module crowns the build. Structure, then motion, then nerve and sight. One machine, ready for bring up and test. Intelligent robots may feel like the pinnacle of modern technology, but the idea is a century old. (1920) in Prague. Playwright Karel Čapek unleashes a new word upon the world: robot. Drawn from robota, meaning forced labor. These obedient human-like workers prophesied a rebellion on the stage. But the word's true revolution began offstage, as it leapt from fiction onto the factory floor. A few decades later, industry turns concept into hardware. Take the 3D jobs, dirty, dangerous, dull, off human hands.
第一台的工业机器人是大概1960左右，乌尼美这家公司出了一个手臂的外形。那这些手臂大家也可以想象嘛，它就其实在一开始发展的时候，就是要替代人去做所谓的3D 的工作。那人这些事情大部分都是用手去做的所以机器人早期在发展的时候，就是以机械手臂为主。
By the 1980s, silicon brains and early vision arrived. The fence pulled back. Robots moved from auto to warehousing, to healthcare, and ultimately to the clean room. Each decade tightens the loop. Smarter control, safer design, and closer to people. After the 72-hour trial, the survivor reaches its final gate. The floor is quiet but alive. AGVs carry the newly qualified arm to the checkpoint. 2 cobots take custody, the last cosmetic look. Lenses sweep the surface. The controller, the arm's brain, stitches the frames into one skin, hunts for nicks, gaps, and crooked labels, then returns the call, release or rework. From the loading bay, the crates set out for their next stage, a factory that runs like a city. Inside the complex line, few humans are visible. They call it a dark factory. Automation runs the work, cycle after cycle. The product is the solid-state drive, a tiny vault for digital life. Memory chips and a controller set on a slim board, then sealed, labeled, and pushed through trial-by-fire checks. It's a clean, dust-tight dance where precision and cleanliness decide what leaves the building. Into that rhythm step the new Taiwanese cobots. With built-in vision and steady, repeatable moves, they take the handoffs people once did. No smudges, no slips, no tired hands.
GM Robot 是我们工厂迈向自动化工业4.0至关东工厂的核心。通过导入 DM Robot 分布于前端产线，然后组装、测试、包装，还有这个仓库，自动化现在涵盖率大概是80%左右。
What once took 10,000 people now runs with less than half. The leaner crew shifts from repetition to refining process and technology. For a factory manager, that's a dream come true.
其实我们带来的一个很大价值就是说，让使用者就是非常好用，这个是我们的一个目标，因为有好用，而且导入快速。 那就可以去解决掉它那些缺工的问题，所以这个是一个解方。我觉得这个未来前景是非常好的。
Back in Taiwan, the Cobot maker crosses the line it drew. An audacious build takes shape.
您好，我是达明的人形机器人 TaiwanPlus， 请问有什么可以为您服务的呢？
从它的外观设计、机构设计到里面的所有的马达，这些基本上都是我们自己研发的。那在这个软体上面，还有算力上面，我们也跟 NVIDIA 合作，还有我们自己的工程师的合作，那我们共同打造这个全台湾第一台人形机器人。
New senses, new moves. Stereo vision for deaf. An extra joint to slip past tight geometry. Fingers that feel. And a wheeled base that glides over real floors with range and poise. Not spectacle. It's a work platform for human spaces and a leap that widens Taiwan's robotics horizon.
的确，这个想象现在慢慢的在发生。那我相信整个世界因为 AI， 因为机器人现在开始投入更多的资金，那更多的人力，这一块的进展就会越来越快。那我们可以期待人跟机器人在一起合作，一起去创造更美好的这个未来。
80 years ago, Isaac Asimov sketched laws for imagined machines. Those pages have since slipped into everyday life. What was fiction now clocks in. Will tomorrow's intelligent, connected robots always obey tidy rules? No one can promise that. But one thing is clear. A new partnership is forming. As tools turn into teammates, the future will be shaped by what we teach them and what we dare to build together.